I'm based out of Toronto, my first time in Vancouver, and it's awesome. I hear that I picked the right week to come out here. Otherwise, I've heard some things, and it's definitely not my experience so far. So, yeah, awesome. If I hadn't signed a lease on a new apartment last week, I probably would have just stayed. So, I won't be. Yeah, thanks everybody for joining. I'll give a bit of a quick introduction to myself. So, my name's Kevin Webber, and I'm a developer advocate at TypeSafe. I've been at TypeSafe for a grand total of 3 months now, so very experienced vet. Before TypeSafe, I was the lead Play and Scala developer on Walmart Canada's new implementation with Play, Scala, and Akka. So if you go to walmart.ca right now, you can kind of see, like, not to give it away, Walmart Canada went reactive, and if you want to see what it actually looks like, you can visit Walmart and order something. So that's my little spiel about myself. But just before I get going, just a show of hands. I know it's kind of a convergence of 3 different meetup groups. So how many people have, say, read the Reactive Manifesto? Awesome. So how many people have also done functional reactive programming? Yeah, so it's a good mix. So you guys might teach me something. So feel free to interrupt me. You don't have to wait till the end for questions. Let's talk it out. So a little bit more context is I started a meetup group in Toronto called Reactive TO. We had our first meetup a couple months ago. It was great. If anybody happens to come out to Toronto and wants to talk, that'd be fantastic. So if you're coming out to Toronto, ping me, and we'll see what happens. So without further ado, so really Reactive, when I came to Reactive personally, I came to the problem that I was trying to solve. I hadn't heard of Reactive. About 2 years ago, I was working with an agency, and Walmart became a customer of that agency. And we had the task of basically guaranteeing that Walmart Canada was never going to go down again during Black Friday or Boxing Day. And we had to code the whole site in about a year. So I personally found that I needed a different approach. Just for a little bit of context, is before that transition, it was JW, it was Oracle ATG. Very high amount of effort to get things happening as far as elasticity goes, which we'll talk about a little bit, resiliency, and all the traits of reactive. But how many people are familiar with the C10K problem in distributed compute and grad? This is how I first started framing it in my own mind of what I was trying to solve. And Dan, correct me if I'm pronouncing the name wrong, Dan Kegel. Basically, it's a call to action. It's time for web servers to handle 10,000 clients simultaneously. And that's back in '99. So, I mean, just for a little bit of context, back in 1999, I was actually a COBOL developer, so I had just graduated. I was trying to fix Y2K and doing a little bit of IBM 360 assembly, and there's this call to action that I had never heard of. So, basically the problem and the tools weren't moving in tandem. So when you get into what the world looked like back in 1999, so the internet had a grand total of 280 million users. And by the way, does anybody know where that's from? Just out of curiosity. Guess? GeoCities? GeoCities is not reactive. It never was. No Facebook, no Twitter. Data was in snapshots, right? So I mean, there was some limited streaming being done. I think Mark Cuban basically made his fortune and bought Mavericks on his ability to do a lot of heroics as far as streaming goes. But back in 1999, I mean, response time in seconds over the web, that wasn't bad. I mean, I didn't personally get extraordinarily upset if LiveJournal didn't load up right away. I just, brewed a coffee and waited. And downtime all the time was kind of the norm, at least my experience. So I may have a little bit of bias now that I'm much older, but the expectations were different, right? And hardware was a lot different in 1999. So typically we had single machines with single cores, limited networking, a mix of broadband, dial-up, intranets, and expensive hardware. So you could scale up. You could provision more resources and scale up if you had a good budget. But for the most part, the hardware was obviously quite a bit different, and the average developer, like myself being what I consider a fairly average developer at the time didn't have to worry about parallelism and concurrency. We'll get into how that's different now. But also, we are dealing with what I would call, so big data is a thing now, small data was a thing. So we're talking megabytes and maybe gigabytes. But even the term big data itself, 1999 was the year. So if you were on the bleeding edge of computing, maybe you read the paper visually exploring gigabyte data sets in real time in ACM. Has anybody actually read that? So I have not read the whole thing. Okay, nobody. I was hoping to see if it was worth my time to read the end-to-end paper. But one quote I like from it is, where megabyte data sets were once considered large, we now find sets from individual simulations in the 300 gig range. So maybe a little bit different, and I'm not sure if anybody's dealing with data sets larger than that right now in the room. I'm sure a few. I won't ask for a show of hands. But that the C10K problem was solved in '99. Again, so Dan Kegel talks about it. One of the busiest FTP sites, cd-rom.com, did handle 10,000 clients simultaneously through a gigabit Ethernet pipe. So the question I would pose is how many other people were doing that, and how accessible was solutioning that problem? And in 1999, I would argue, not very. So let's fast forward 15 years later to today. Expectations have changed, hardware has changed. And here's a cool quote. I don't know if anybody's familiar with Urban Airship, but this is a cool quote from Scott Andreas, and that's, if one node can only serve 10,000 clients, the venture is cost prohibitive from the start. Just 1 million devices would require a fleet of servers. So I mean, you're getting into, yes, you can basically use any technology to solve any problem, but at what cost? So we have the problem of concurrent connections. We have the problem of big data. How much does it cost to actually solve these problems? And let's look at a little bit of contrast. So in 1999, the internet had 280 million users. 2005, the year that Ruby on Rails was born, 1 billion users. And today we're on the cusp of eclipsing 3 billion users. So just remember the 280 million mark. So in 1999, MySpace, Friendster, GeoCities, LiveJournal, these were fairly popular sites. But now we're dealing with 2014. Twitter alone has 270 million users. And Facebook, actually, I think that number's wrong. I looked it up again. I actually think it's closer to 1.2 billion users. So when you're thinking in terms of usage, Facebook alone now handles the user base of 4 internets, circa 1999. So if we try to apply the same, and not even technology, not even toolkits, but the same approach. So myself, I started with Java. So I was still doing COBOL in 1999. I started to teach myself Java 1.16. And I found that when I started on the Walmart project, my approach had changed a little bit, going from J2SE to Java Enterprise. But for the most part, I was still trying to map basically the Java domain on top of the internet and kind of coming up short in a few areas. So, so obviously we need something that talks the language of the internet, but also makes it easy to do a few things that I'm going to talk about shortly. But hardware is also quite a bit different in 2014. So instead of a single machine, we have clusters of machines. Instead of single cores, we have multiple cores. Slow networks, fast networks, and small data is big data and streams of data. So dealing with a stream of data where you don't know what the bound is, that's a lot different than dealing with a fixed size of data. So the other realities of development today are that applications are distributed and they're composed. But one of the things that I was looking at more on working with the product owners of Walmart was the expectations of responsiveness have changed radically. So, I mean, I don't know if anybody's seen the clip of a baby about 2 years old using an iPad. and then somebody replaces it with a magazine, and it doesn't know what's going on. So these are this is the future user base of our technologies and the applications we build. Is their expectations are going to be radically different, and just you know, even my own, right? So now I consider a slow application to be dead. Like my patience is a lot different, and users expect, you know, basically coding once, and that application is basically going to fit a number of different devices. So, you know, building one off per is, yeah, not quite a thing anymore. So, so developers can no longer avoid parallelism and concurrency, and even for the average developers like myself. So obviously we need an accessible paradigm. We need to start thinking in terms of how do we do things a little differently to make it easier to solve these complicated problems rather than, you know, sort of more complicated. So in 2010, the Urban Airship used pure Java IO to successfully test a lot of concurrent connections on a single 2.5 gig EC2 instance, which is fairly cool. And so we could say that C10K has become C500K. But that's not quite true, because migratory data scaled up 12 million concurrent users from a single server, pushing about a gig of live data. Yeah, so I mean, it's quite a bit different. I mean, when you're thinking about C10K is now C12M. So I don't know if anybody's written a good paper on this, but I'd love to see one. If you come across the C12M, we might be dealing with C20M and so forth. But basically, long story short, is that sort of like gather around the campfire history lesson is just to kind of provide context on, at least for myself, you know, why did I personally become curious to find a much easier approach to kind of satisfying the needs of users, and also basically maintaining a consistent user experience regardless of kind of what's happening behind the scenes. So I want to kind of shift it. Yeah, go ahead.
What was the size of the EC2 instance?
It was, let me just double check. So 2.5 gig. So yeah, the principles of reactive application development. So there's functional reactive programming, and then there's reactive application. So they're slightly different things. So I'm going to talk about anybody that's seen the manifesto's version of it. It's going to be a little more aligned with that than something like RX, whatever. They're both related. They're a little bit different. And yeah, I'll discuss it, and then feel free to cut me off and ask some questions. But this is a cool quote that I like from Jonas, and that's, instead of the latest framework of the day or the latest buzzword, reactive brings the talk back to core principles, the design, the architecture, and the way we think about building software. And that quote resonated with me quite a bit when I was thinking about, you know, why do I want to retrain myself completely on how I approach a problem? And the sort of long answer is that I knew that I could do what I needed to do with the technologies that I was already comfortable with in the paradigm, but I also knew that it would involve quite a bit of heroics. So I wanted to look for something to make my life easier. And then I came to reactive. So what is reactive? If you want to see the longer winded version of this, I did put up an article on medium.com, and it's called What is Reactive Programming? So after this, feel free to go on Medium, look it up, and then comment in line. Because one thing I want to point out before I go any further is what we're doing with reactive TO is this is an emergent paradigm. So it's not just, you know, me coming out telling you what reactive programming is today. Like, I would love to hear feedback, and the manifesto is basically a living document, and so is my own interpretation of what reactive is. I do sort of have my own opinions on it, but, you know, I mean, this is a community and a collaborative effort. So definitely, yeah, definitely ask away, and we'll evolve this. But I don't know if anybody's familiar with this diagram. Who's seen this before? Does everybody kind of like, is it very intuitive? Because I want to kind of like go up. I find it intuitive now, and we're going to really dive into it. But one thing I just want to point out is that the direction of the arrows means something. And really the reason responsive is on the top is because that's the ultimate goal of reactive application development. So when I start to think about what is reactive, I think in terms of my goal is responsiveness. And the way I get there, the traits of my applications need to be scalable and resilient. And event-driven or message-driven, and we'll talk about some of the slight differences in terminology between event messages and actor-based systems, that provides the core, right? So let's just dive right into it. So Jonas did this at ReactConf. I kind of like it. It's actually just taking sort of what these terms mean. So reacting quickly and positively. I think that's a good way to kind of frame responsiveness. And so one of the things when you start thinking about responsiveness is thinking about what is going to block your UI, what's going to kind of get in the way of your user from doing whatever they came to your application to do. And one of the things is never to allow slow external dependencies or flaky external dependencies to degrade the user experience. And never assuming blue sky. So I know, myself, personally speaking, for about a decade, I built software. And a lot of it was happy path based and sort of kind of grafting on a good resiliency model after the fact with, throwing things and catching things, and it's hard to get right. So one of the things that, some of the toolkits that we're going to talk about a little bit take that to the core level. So basically, reactive, I would say, is putting gray skies at the forefront, building out for that. So basically going into development, knowing that things are going to go wrong and having a good programmatic model to deal with that. But one of the things I just kind of want to talk about is, there's 4 combinations of toolkits, especially on the web, and that's synchronous and non-blocking, asynchronous and blocking, synchronous and non-blocking, synchronous and blocking. So I don't know if anybody can kind of spot the problem, some of the things that may start to block us in terms of responsiveness. I won't give it away. But before we go any further, what's the, and I'm making no assumptions. How many people have delivered a fully asynchronous app to production? So end to end. Yeah, it's actually difficult. I mean, even now. So at a certain point, you're probably going to block along the way if you're dealing with a relational database. So if you're, say, play in Mongo and using the reactive Mongo drivers, you're asynchronous end to end. But the thing is that at least breaking it out in terms of getting the low-hanging fruit asynchronous, you're not bounded. You're basically bounded by the slowest running process. Check.
Just wait until the green light goes on.
Okay.
Hopefully it hasn't.
I'm just going to yell for now. Okay. Okay, I'm back. But staying synchronous, I mean, you're bounded by. Holy shit. I'm not going to. Yeah, I'm going to react. Gray skies. I've got to use my voice now. You're bounded by, oh, and by the way, if anybody can't hear me, like you talk loud, so I think I'll be okay, but if you can't hear me back there, just yell louder than I'm talking. You're bounded by the aggregate of all of your processes, right? So I mean, that's a very simple reason why you would want to go through the effort of kind of inventorying your systems and figuring out, why you may want to implement completely asynchronously. So, just to demonstrate some code, I could talk on and on about, sort of at a high level. I just want to throw a few things out there code-wise as I talk, and because I happen to know the type-safe reactive platform, I'm going to use those as examples, but feel free to sort of cut me off and we can chat. So this is at a very high level, sort of a day in the life of an HTTP request on Walmart.ca right now. So what our team did is we used Play as a container for multiple single-page web applications. And really what the goal was is to ensure responsiveness at all times. We really had to start to slice out, the data that we were trying to present on the UI.
And so we came up with this kind of model using play, and it's to render sort of a minimally, like we talk about MVPs, right? I would say a minimally viable page rather than the product. So we were doing that initial page render with very reliable and performant integrations. And so once that sort of initial page was rendered, then we're basically going and sort of starting to load up all of our static assets from, we use Akka. And then we're kind of going back to play and starting to progressively enhance the UI. So if anybody wants to see this in action, just load up Walmart.ca, and if you look hard enough, you might actually notice all the add to cart buttons start to pop up. And so the reason we do that is because we try to cache as much data. We try to cache as much data as humanly possible. But there's some stuff we need in real time. And it's those real-time services from sort of unreliable or unknown legacy backend services that can block that initial render. So the idea is that your initial render is going to kind of present the minimum amount of information. So we decided the minimum is to be able to browse products. And if for whatever reason we couldn't get pricing or availability, then we could add that after the fact. So at the very least, they could surf the site, and we weren't sort of fail whaling the entirety of the application. And this is a pretty sort of trivial kind of overview of how we're using twirl templates in play. And if you take a look, that this HTML here is basically just a function that is getting passed to twirl, and twirl is rendering the HTML. And customer at the very top is just the function definition. So we're basically passing a function and kind of shipping that code off to twirl. But so some of the cool things here is the fact that we could use play to handle all of our top level navigation. So we could basically slice the site up with 5 single-page web applications. And it was an AngularJS app also, so we could just kind of plug that single-page web app into the ng view and kind of have the best of both worlds. But sort of the gist of it is that main template, that's kind of what we were, and it was a little more complicated than what I've displayed, because it's all, the entire site was driven by a content management system, so we had a lot to do, but to get that MVP up. But the idea is that MVP, we were almost 100% sure that we were never going to block on flaky or unreliable services. So, you know, the idea is to start to do that kind of deep dive on your data and you know, see what's flaky, what's reliable, what's slow, what's fast, and figure out how to progressively enhance your UI. So I'm going to go out and just try to like define responsiveness myself, and I've defined it personally, and feel free to correct or disagree, but I personally think it's being quick to react to all users of the system under blue skies and gray skies in order to ensure a consistent user experience. So when I say consistent, has anybody visited Guild.com? It's a flash sale site, shopping site. Yeah, Guild is a really cool use case on responsiveness because they actually, so every day at noon they launch these flash sales, and they actually get a 100, not just like a 10, they get a 100-fold increase of traffic at exactly noon. Eastern Standard Time from what I understand, but basically sort of rolling through the day. And you would expect from a user perspective, if you can still visit the site before they announce the sale. So at 11:58, 12:02, you know, a good user experience, that should feel the same. Like at 12:02, you as a user don't care that they're going through this huge burst of traffic. So to implement that, you know, non-reactively would be very, very challenging. So that's like one problem space. This is John, by the way, from TypeSafe, so he's going to do a blurb at the end. Hi, John. So anyways, that's responsiveness. Let's dig into scalability. So the textbook definition of scalability is being capable of being easily expanded or upgraded on demand. And really we're talking about, you know, what I like to look at is that term elastic at the bottom. Get into why a little bit. But there's two things that I just kind of want to throw out there. And performance. Sweet. Okay, so performance is a measurement of response time, and that's the goal. We want performance systems. I think everybody can agree with that. But then there's this enemy of performance, which is load. And if not handled properly, it basically negatively impacts performance. So there's two ways to deal with that. I think the traditional way, and the way I was used to for a huge chunk of my career, was to scale up. So faster CPU, more memory, bigger hard drive. And that's a more efficient use of existing resources, or being able to sort of upgrade what you already have and kind of squeeze more performance out of it. Scaling out is more, so we talk about concurrency and parallelism. Really the goal of scaling out is distribution work, right? Because if you're able to distribute, you have something called location transparency, which I'll talk a little bit about. The distribution is what kind of gives you concurrency. So I'm going to show some examples with Akka, and just context. How many people have done Akka or Erlang development here? Lots of people, sweet. So feel free to teach me something. So as the play lead and the team lead of Walmart Canada, I ducked into Akka when I could. I'm still ramping up. I love it. I find the fact that I can do a lot of these complicated things very easily with Akka is absolutely wonderful. But I'll give a high level for those who haven't done any Akka development. So basically, Akka is actor-based. And we'll kind of get into the difference between, so when you're talking about message-driven, so there's the Node.js style, which is basically eventing. And then there's actor-based systems, which are message-driven. We'll talk a little bit about the difference between the two of them towards the end. But actors are these wonderful things which enable very easily communication across all sorts of boundaries. So that's what I mean by location transparency, is you don't particularly see if...
Check, okay. Which enables you to not necessarily care at a programmatic level. I mean, very subtle differences when you're talking about sort of distributing these actors across JVMs or across the network. But at the core of the actor model is that you start to think of in terms of directing messages from one actor to the other, so that the flow of data is important. And pure message passing enables distribution of work, which provides concurrency. So this is a very, very simple, but this is the good thing, is a lot of Akka code looks fairly straightforward. It's very easy to reason about. So I don't know if any Node developers have kind of found themselves struggling with the pyramid of doom, but you don't in Akka. I'll explain a little bit why later. But for imperative developers like myself, Akka is wonderful. So what we did use Akka for quite a bit on the Walmart project is actually saving a lot of legacy data. So we could use the isolated state, we could still kind of keep that imperative style, but we could also make sure that the boundaries were very clearly defined with pure message passing. And I just wanted to kind of throw out a little reference architecture. So if you're using play, you can get into cool things like this. So you can sort of handle the request at the play layer. You can kind of distribute that out to an Akka router, and then distribute it amongst a lot of workers. So it's not super complicated to do that. And this is the difference I was talking about, the difference between creating a remote actor and referencing a remote actor. If you see that creating a remote actor is fairly straightforward, referencing is sort of fairly straightforward. You can obviously pull some of that out into configuration, so you're not hard coding it. And at a configuration point of view, this is really all you need. I mean, there's more when you get into clustering, but it's giving you a lot for a little bit of effort, which is wonderful. So scalability. I would argue that it's the capability of your system to be easily upgraded on demand in order to ensure responsiveness under a variety of load conditions. So that's a trait. So that's a trait that's feeding into responsiveness. And resiliency is another trait of reactive applications that feed into responsiveness. So it's the ability to recover quickly from difficult conditions, and that's really what it is. So there's a few terms that I'm going to throw them out here, and I hope hope it gives. How many people are familiar with all of these three terms? Has anybody implemented this at a code level? Production, bulkheading. How about circuit breakers? Is anybody? Well, a few people. So I'll talk a little bit about this, but really resiliency is about trying to figure out, like I talked about, when you're thinking about terms of minimally viable page. This is the stuff that's going to come in really handy, especially circuit breakers if you're interacting with legacy services. But the idea is that whenever possible, you want to make sure you kind of start to split up your work. So bulkheading is when you're thinking about thread pools. For anybody that's worked with Java and thread pools, it's making sure that the type of work you're doing in one thread pool is your thread pool's tuned to handle that type of work. So if you have basically a lot of heavy memory usage, you may not want to throw 1,000 threads at it. You may want to artificially limit the number of threads to preserve memory. Whereas if you have a lot of CPU-bound work, you may configure that thread pool quite a bit differently. So bulkheading is basically just partitioning thread groups for different functionality at a high level. And Play gives you this side of the box, Akka gives you this side of the box. Circuit breakers is another sort of resilient pattern. And that basically really leads to stability. So the idea is that how many people have dealt with timeout exceptions? So you go to an external service, timeout exceptions. The problem with timeout exceptions is, let's say you have a legacy service and it's failing. You're going to hang on to that. So it's timing out, but how long are you going to hang on to your thread? Threads are very precious. So you may hang on to that thread for 30 seconds or 60 seconds. That's when you get into thread starvation and you start to run out of resources. So the idea behind circuit breakers is to treat threads like very precious commodities. And you can actually take, so if you go through a round of performance testing, you can actually take what you've discovered from performance testing. So let's say I'm going out to service A. I expect that to come back in 1 second. I can actually take that out of a testing context and actually make it a programmatic concern. So you're almost getting like this test acting in runtime. And we'll I'll show you how that looks. So I'm going to demonstrate circuit breakers with both Akka and Play. So this is what I was talking about at kind of a high level. So really circuit breakers, there's 3 states. So when everything is running accordingly, it's all good. Basically you've said, okay, I want this service to respond within 500 milliseconds or a second or whatever you've decided. So the circuit breaker is basically monitoring that communication. And as long as your sort of performance thresholds are good, then your circuit breaker is closed, and basically your runtime never even has to think about the circuit breaker existing. But if for whatever reason your legacy service, or any service, anything you're doing, you can kind of wrap in a circuit breaker, and what happens is if it goes outside of the bound that you've configured, it trips. So it doesn't seem like you're getting a lot until you start to think about what's actually happening, in the sense that that thread, instead of waiting around for that timeout exception, you're basically doing that once, but once the circuit breaker trips, you're failing very fast. So you're letting the thread go, and now you're dealing with circuit breaker exceptions. But then so now your app is basically, the circuit breaker is tripped, communications to that service are blocked, right? Your app is now returning circuit breaker exceptions that you're handling instantly. You're not sort of bogging down and tying up threads with timeout exceptions, which would be completely useless if there wasn't a way to automatically, without manual intervention, try it again and go back out to that service. So the idea is that you're kind of waiting for your service to kind of heal itself, right? Especially if you don't have direct control over the service. So what happens is you can also specify a number of seconds or however long you want to actually go back and try the service again. If it comes back basically with the same problem, then the circuit breaker opens back up again. But then if it works, so it only lets sort of one message through, and then if that one fails, it opens again. But if it succeeds, then it closes, and then everything is back to blue skies. So I just wanted to kind of demonstrate. I'm not going to go through the code too much, because this is how many Scala developers are here right now? So this is Play Scala. Okay, cool. So there's quite a few Scala developers here. This is you know, how I've implemented it. If there's other more idiomatic ways to do this, I'd love to hear it. Basically, what this is doing is just what I talked about is configuring all of your specs, right? Your max failures, your call timeout, reset timeout, and then creating your circuit breaker. And the idea is, on open, you can do some alerting, you can do anything you want, but you're going to return the circuit breaker. And now this is basically what's going to happen when you're catching open circuit breakers. So I won't go too deep into this, but the idea is that you're going to fail fast, you're going to recover, you're going to start to deal with these. Instead of timeout exceptions, now you're dealing with open circuit breaker exceptions. And so now this is what your actual play controller code would look like, is you've got this future result, you're basically wrapping it with the circuit breaker, and then you're catching open circuit breaker exceptions. So if everything's okay, that happens. If everything's bad, the other thing happens. So it's pretty straightforward. Again, a little bit of not the complete code, but not super complicated to implement. And definitely the effort of implementing circuit breakers. This is an Akka pattern that's with the play Akka interop, basically provided through Akka. And the effort involved in implementing these at runtime is pretty incredible. So I've already kind of ran through this, but the idea is that you just don't want to let things kind of go on and sort of overwhelm already strained services with more requests and prevent them from kind of like healing themselves. So you want to prevent cascading failures and codify strategies for addressing the inevitable failures of your external systems. And just preparing for failure early, so bringing that, you know, that's the kind of stuff that I used to do in a performance testing context, and I've brought it into my sort of live code. So I'll define resiliency as the proper application of some fundamental design and architecture principles to ensure responsiveness under gray skies. So event-driven, this is where it gets fun. This is the foundation. So event-driven is actually the core of what enables both scalability and resiliency. So I'm just going to kind of try to blast through this. There's a few traditional concurrency models that some of you may have worked with. There's one that I haven't worked with at all yet, but basically the traditional sort of thread-based and sort of objects, mutable shared state. How many people are kind of in that world right now? So you're dealing with a lot of sort of global shared mutable state? A few people. So yeah, I dealt with that for a long time. And it's very hard to reason about code that looks like this. So I would say that this is a very common paradigm, Java Enterprise Edition. This is, you know, sort of container-based deployments. Wicket's another example of, you know, basically full statefulness. You're dealing with imperative sequential execution, threads for concurrency, shared mutable state. This is another one now. Has anybody worked with, so are there any Haskell developers here? Yes. So have you worked with STM before? I have not. Sorry?
Clojure also has STM.
Yeah, so I'm not sure if I mentioned that in here. I tried to look at, yeah, I got Clojure in the bottom. I tried to go and look for all the implementations of it. I would say this is traditional concurrency. I don't want to talk about this too much. I just wanted to put it out there for kind of, you know, compare and contrast if you want to look it up. But it's basically when I looked at it, when this kind of came on my radar, I thought of it almost like command pattern, command interface. So now it's event-driven concurrency, so thread-based event loops. So at the very bottom, you can kind of see a few reference implementations of this model of concurrency. So how many people are working with one of these at the bottom? So Node.js, Twisted Python Event Machine. This is share nothing concurrency. This is definitely one way to implement it. And actor-based concurrency is another way to basically be share nothing and event-driven. So there's a little bit of mutable state. Sometimes you can go completely immutable with actors, definitely. I am pretty pragmatic in my approach and my usage of Akka, so I don't worry too much about some mutable state because it's all within a bound, right? So it's the asynchronous message passing, it's the messages that basically make sure that you're always easy, it's always easy to reason about your code within an actor because you can see within the actor what type of messages it can respond to and deal with. So you're thinking again in terms of flow messages rather than time and space and mutation. So I'm going to do this, and now this shared mutable state looks like this, and I have to wonder about who else is operating on it. So, after doing not this talk, but sort of the first reactive TO meetup, is we got into a cool discussion about what really the difference is between events and messages, and kind of went away and thought about it a little bit. And this is sort of what we came up with: is that events happen, and that interested observers must kind of watch and wait and respond. And a lot of the times that's happening with anonymous function callbacks, right? So that can lead to the deeply nested sort of pyramid of doom. And whereas messages are directed. So because messages are directed to one receiver, broadcast to a number of receivers, you kind of avoid that. So it's not that one is right, the other is wrong. Both of them are event-driven, and both of them lead to resilience and scalability. So it typically depends on, I would assume that whatever your preference is as a developer. So my preference is definitely messaging, because I just find it works pretty well with the way I think. So I'll give it a shot to define this, is that message-driven architecture forces programmers to deal with scalability and resilience at a code level in order to facilitate responsiveness. So this is kind of like where we're coming to, is what is reactive, and that it's responsive to stimulus, so it's always responsive. So it's the traits of reactive applications, the core of the message-driven core leads back into this. So now, hopefully, if this talk was any good, now the arrows, for anybody that hadn't seen this, probably make quite a lot more sense in how everything's feeding into responsiveness. I definitely want to give a shout out to Erlang. So Akka is heavily inspired by Erlang, and Jonas is a big fan. Are there any Erlang developers here? Awesome. Yeah, so definitely come out to Toronto and give a talk. I've been trying to find an Erlang dev to come to Toronto and give a talk. So if anybody hacks on it on the weekend and gets a hang of it, come out. So Erlang characteristics, sounds familiar, right? Share nothing architecture. Processes can't share data, so everything is driven by pure message passing. And crash detection and recovery, so things will crash, let them crash, recover. And this is definitely, so this actor-based model is definitely in production right now. So here's a few, I won't go through all of them. I know a few people, I've talked to a few of you folks earlier, and there is some RabbitMQ happening. I don't know if anybody else is using any of these others. So I just want to kind of round it out with a cool quote from Jonas, which is the fact that, you know, we're not really defining anything brand new, but we're looking back in history, and Reactive doesn't ignore the knowledge that's been around for a long time. It just tries to bring it into the new context, the new problem space that I talked about at the very beginning of the talk. So I just want to kind of give a shout out to some of the folks, some of the talks that I really like on Reactive, so feel free to go and check these out. Yeah, Jonas Bonaire, Joe Armstrong. Martin Thompson gave a great talk at ReactConf, so if you Google that, I highly recommend it. He's working with a lot of sort of like high-frequency trading applications. So that's the talk. So thanks a lot for hosting me, and I'm pretty happy about coming out to Vancouver this week. Beautiful weather, and yeah, thanks a lot. I'm also going to introduce my colleague from TypeSafe, John. This is your cue. So thanks again.
name is John Meyer-Hoffler, and I am a colleague of the Akka Kevin Webber. I just wanted to make sure that you all knew what TypeSafe did. So we are the corporate custodians of the projects, Scala, Akka Play. We support those projects from a community basis and also from a commercial basis. So we make sure that you guys can learn these technologies and that you have the support and training you need and other interesting learning vehicles. We also supply training and consulting in conjunction with great partners such as Go Reactive, who help make this happen today. So we just really want to see you guys be successful with this set of technologies. We love it. We're disciples. We live it every day, and we want you guys to experience the same joy, really. You know, I've had developers tell me they've never had such fun in their lives programming in Scala and using Akka, and that makes me feel great. So if you have any questions, see us afterwards, and I don't want to take up any more of your time with anything not involving code and technology.
Yeah, so I think we're, maybe I can to kick it back. So we're gonna go out for drinks, I don't know where. So for whoever, so feel free to ask me some questions now, or let's go grab a beer, whatever your preference is. For anybody not coming out of beer, just, yeah, fire away. Yeah?
What are you guys using for monitoring JVM, Akka-based messaging, things like that?
Yeah, so there used to be, I'm not sure if anybody... Oh, sorry, asking about Akka monitoring. So I'm guessing you mean in production?
Yeah.
Okay, so there used to be the TypeSafe console. At the moment, we basically just increased our third-party integration. So now, definitely recommended to check out. There's a list that I can give you of third parties. We have official partnerships with New Relic and AppDynamics right now. On the development side, check out Activator. There's actually, I don't know if how many people have taken a look at TypeSafe Activator? Yeah, how many people have seen the inspect tab in TypeSafe Activator? Yeah, so on the development side, that's the best way to go. On the production side, we're not basically making any strong, so it's sort of like opinions on it, but definitely check out the third-party integrations. There are some other things in the works, but yeah, that's about it. Any other questions pre-drinks?
You mentioned, you asked if, how many of us have done end-to-end basic applications, and you said it's sort of hard to do it with relational databases. Has that changed at all? Are there any relational database drivers that are basic now, especially for like MySQL?
Yeah, so just to repeat the question I mentioned earlier in the talk, so I asked, about how many people are end-to-end async. And also using relational databases. The answer is I don't think that there's any completely async relational database drivers. I would love if somebody can correct me.
There is one based on Netty, Postgres and MySQL.
Okay, so there is one based on Netty, Postgres and MySQL.
It's still fairly early.
Haven't used it?
Yeah, we use it Postgres.
Yeah, so perfect. there is the ability to go end-to-end even with relational databases. If you're not able to go async completely with relational databases, that's when bulkheading gets to be pretty important. Circuit breakers. You basically want to kind of push. You want to kind of push the block.